Hi guys, my name is Carlos Balsalobre and I'm the lead author of the paper entitled The Validity and Reliability of an iPhone App for Measuring Running Mechanics. Well, why did we do this research? Okay, there is a large body of research highlighting the importance of monitoring running mechanics for both performance and injury prevention purposes. Although the main problem is that the instruments considered the gold standard for measuring running mechanics are quite expensive, like force platforms or instruments treadmills. In this sense, many strength and conditioning coaches and physical therapists can't measure running mechanics because they can't access this expensive material. Uh, in an attempt to solve this problem, there was a very nice piece of research by Dr. Morin back in 2005 in which they created a biomechanical model in which contact and aerial times could be used to calculate leg stiffness, vertical oscillation, step frequency, and maximal force of each stride in a valid, reliable way in comparison with a force platform. In this sense, just by using some basics anthropometrics like leg length or body mass and measuring contact and aerial times, authors developed a very nice model that could predict force, leg stiffness, and other running mechanics in a very valid and reliable way. Considering this and taking into account that previous studies have shown that an iPhone app named MyJump, maybe some of you have heard of it, could measure flight time of vertical jumps in a very valid and reliable way, thanks to the slow motion recording on the iPhone. The purpose of the Brazilian study was consequently to analyze if a new developed iPhone app based in the same principle, the slow motion recording, could be a valid and reliable tool to calculate running mechanics. So what we did was to first create an app. Some of you might know that I'm also an iOS developer. So I developed the RunMatic app back in 2016, and the app was designed to use the slow motion recording of the iPhone in order to accurately detect the contact and takeoff frame of each step while running on a treadmill, and subsequently to calculate contact and aerial times of each step. So what we did here is to record several trials of 30 seconds running on a treadmill at different speeds from 10 to 20 kilometers per hour. So what we did is to run on a treadmill at different speeds and compare the same steps with our reference method, which was an OptoJump infrared platform, and the RunMatic app. And basically, the RunMatic app user interface is like this. You record the athlete from behind and manually select the contact and takeoff of each step. You need to record 8 consecutive steps. And as I said, we compared the same steps with RunMatic and the OptoJump. And that's what we found. Basically, we observed a very nice correlation that are expressed in this table. And basically, for all the variables we analyzed, the contact time, aerial time, vertical oscillation of the center of masses, the maximal force and leg stiffness, we observe very low absolute bias and very high Pearson's correlation coefficients. So another important finding was that when analyzing each set of 8 steps to test the reliability of the app, we observed that both the RunMatic and the OptoJump had almost identical coefficient of variation and reliability levels. So basically, If you use RunMatic, you can track over time the change of your athlete because the measurements are really reliable. Therefore, in my opinion, this paper has an important practical application since it proves that a very cheap iPhone app, specifically designed to measure running mechanics, can actually measure leg stiffness, vertical oscillation, contact time, aerial times, etc., in a very valid and reliable way in comparison with an expensive reference method. And I think this could be of great interest for strength and conditioning coaches and physical therapists who can't access expensive laboratory equipment like force platforms. So thank you very much for the interest. If any of you want to see more of my work, you can find me in ResearchGate and also in Twitter at cbalsalore.